Live. Okay. So, I'm just going to go, and if I see drops happening again, then I'm pulling the plug and I'm going to stream off, or I'm going to program off stream today. But I think I'm actually able to get started now. Between connecting to a better server and tweaking the bitrate, I think I've got it staying steady now. Okay, so the first thing I want to do is these shaders here. They are being just hard-coded in like this, and that's not actually a huge problem, except that I don't want to write shaders without indentation and inside of my CPP files. It's just not the way I like it to go. So what I'm going to do now is up here at the top I'm going to include out of generated my jam2 shaders or GPU programs .h. And then what I'm going to do is we're going to come over here and we're going to mixer generated. We're going to go over here and check out the build.bat. And let's see, what have we got so far? This pushes build jam2. Okay. It's so hard to make out comments in this language. Like, it's so hard to recognize a comment in amongst the other text. So for this one, what I want to do is build the GPU preprocessor. I'm going to link user32lib on that for reasons you'll see. I actually thought about this a little bit this morning. So I have the unfair advantage of already having a plan that I haven't described to you. And then I'm going to put the standard link right there. And then what I'm going to do is run the GPU preprocessor, which basically goes like this: preproc /code/ GPU programs.txt code /star.glsl code not sure that that's the way I want this to work. I'm going to do at least this much. Okay. So now when I run build, it's going to say I can't do any of this stuff. I don't know what you're talking about. The generated header doesn't exist, the GPU preproc doesn't exist, and so on. Now the first thing I'm going to do is I'm not going to satisfy any of that. I'm going to make the problem just a little bit worse, just to fully commit myself to the thing I want to do. This is going to be my jam2 we'll call this vert basic.glsl. And I'm going to put comments on that the same way I do for all of my files. Let's see, today is September 30th. Yep. And jam2 basic vertex shader. And then what I'm going to do is I'm going to take all the code here. I'm going to pop it right here. I'm going to take out version and keep the rest. And I'm going to do the same thing for jam2, save that, jam2 frag basic.glsl. Okay, so that gives me a vertex and fragment shader file, which is, okay, we're going to get that up and running now. Now the way I like to get that up and running is I'm going to pre-process a bunch of files and put them into this GPU programs header. And that is where this file comes into play, jam2 GPU preproc.cpp. Shader or GPU program preprocessor. So the GPU program preprocessor is going to be a basic command line kind of utility. And I'm going to start by just getting, I'm going to use like standard C library stuff for this. Just because I want to get it up and running quickly, and this isn't the kind of thing where I'm going to the point of it is to be easy to maintain and run on the dev machine, and it's never supposed to run on any other machine. So the trade-offs are different enough that I consider it makes perfect sense to use standard libraries heavily in this case. Alright, so I need to include jam2 defines, I believe is the header. Yep. Alright, so there we go. It just showed me, here's the output from my preprocessor to GPU preproc programs.txt. So that is up and running, and that's good. It can compile and build that. Now the next thing I want is, I want to add safe assert capabilities. So this is kind of a neat thing. I'm going to have a switch for turning it off. If defined jam2 no long jump. Then what I do is we're going to say let's see, assert goes here. This assert goes here, and this is going to be like if has safe assert is greater than 0, then I'm going to do the safe assert version. Else Really what I ought to do is also include that there. So if we fail the condition, if we're doing safe assert, do something else, do something else, and close the if, close the do. We have to do something here. And then this becomes global U32 has safe assert, which we set to 0 initially. And now begin safe assert. Whoops. End safe assert. Look like that. That'll do nothing under this condition. And this sort of direct assert will be what we do when we're not in safe assert mode. Tamela asks, what's the point of the do while 0? The idea is syntactically, right, if I write code that looks like this ever, which I usually try not to write this kind of code, but suppose I were to write like if sev level equals to assert you know, I don't know, assert user data is not equal to 0, right? If I were to write this code, then if you don't have the do while 0 there, then you actually, what you get is a little bit weird, because imagine I don't put the do while 0 there, then this expands to like if some condition, then if some other condition, I'll call it D, do this, else do that, and then a semicolon here. If I then go else, this is actually syntactically just wrong now, because this if here had a statement, and then a semicolon became another statement, so there's no else attached to that. Similarly, this if has the statement that goes from here to here, and then that semicolon closes it, so that else actually is incorrect. It can't bind to either of these like it should. Now, what you actually want it to do is you want to treat all of this as kind of a block and not have that semicolon there. But the problem is, well, there's a couple problems. First of all, if I just in the macro put the block there, then that semicolon still doesn't get consumed as a part of that statement. If I use any other kind of looping mechanism, like this, for instance, with like I don't know, like k equals 0, k does not equal 1, k equals 1, right? Something like this, where you're like saying kill the loop after one step or something. That semicolon still won't get consumed. The only way to consume that semicolon and put a block around the code is to use a do while. And the 0 just says we're not actually looping, we're just trying to consume that semicolon. So that way, if I write something like this, assert user data does not equal 0, else assert user data does equal 0, it will get parsed correctly because the do while 0 consumes these semicolons correctly. It's a bit of a hassle, and sometimes I skip it, or like use, if I don't need to use ifs, I'll use comma operators instead. But it's just, I don't know, it doesn't cost me that much mental energy to get it in there, and then I don't ever have to like get confused by my macros if it accidentally becomes an issue later. Okay, so now the next thing we need is we need to include long jump, and I'm gonna pull up this C long jump. So we need this, And the good news is the stream appears to be working fully correctly now. So we need that, and we need a long jump buffer. It's actually going to be a B32, so if it has a safe assert, else. Okay. And then what this is going to do is when I begin a safe assert, I want to set a jump, and then when I hit the assert, I use the long jump to go back to it. Okay. So what this basically lets me do is I can say, when I begin the safe assert section, I'm going to put down a brace. This time I won't use do while because I actually want this thing here and this thing here to introduce a scope. And the reason I want that is basically until the end of safe assert, any asserts will cause a long jump, and I don't want like declaration order weird things to happen. So anything declared inside this block shouldn't be allowed to exist once we assert out of it. Okay, and then what we're going to do is first I'd like to assert that has safe assert is false, and then we're going to set that to true. Has safe assert is equal true, and then what we're going to do is we're going to set the long jump. Set jump. Let's see. Just put the buffer in there without. Okay, so that's probably a macro. You can tell that set jump is a macro because you don't pass it the address of this thing. You just pass it directly, and it does something goofy. And that's going to look something like this. So now hold on. Don't play a bunch of ads at me. What I want to know is what is the initial return. Set jump position using buff and return 0. Got it. Okay. So the first time I call it, it's going to return 0, which means it won't do what's in this block here. But the second time I call it, or when I return to it, it'll return 1 and then go down this path. And what this path is going to do is it's going to go to end label. Okay, so that introduces a label for it to jump to. Now the other thing I want to be able to do is I want to be able to say when I do this, and this is also that, by the way, I didn't explain this, all this stuff I'm doing with safe asserting is so that if my preprocessor asserts, I want it to not crash the compiler, like the build script. I want it to gracefully report the assert as a fprintf. Alright, and then let's see. So I char star safe assert message, right? And so if we get here, we'll come here, and then what I can do is say something along the lines of, I want to rename this to like L for label, and this is going to be like E for error, right? What will happen is E is just going to be pointed to the safe assert message, like that. And And before we go through, I'll also have this just set the safe assert message to 0 right away. So when we first begin a safe assert section, we set the fact that we have one to true, and then we set the message to 0 so that if we already had a message, it gets cleared. And then finally we set a long jump point, and we're done. Now here what I want to do is first hold on, that's not quite right. So when we jump to the end, or if we get there without jumping, I want to set has safe assert back to false. And I'd also like to say that we assert ahead of time that that has safe assert was true. So when we get done with that block, we first assert that we still have a safe assert. Then if we have a message, it goes into E, otherwise E gets set to null, and then we set this back to false. Okay. So that just means these down here need an L and an LE. Okay, cool. So now I'm going to go to the GPU preproc, and I want to put this into action. I suppose the other thing I should do for now is I want to build no jump version, which will basically be just somebody who defines this, and then everyone who's not a preprocessor kind of dude will have that. So I don't want them including the long jump code. But the preprocessor will include the long jump code, and so I can do begin safe assert GPU preproc, for instance. And safe assert. And since I want to carry out to the outside of this block the error, I'm going to set the error to 0 outside of the safe assert block, and then I pass the error into that macro there so it can get assigned. And if error does not equal 0 at the other end, then we can just fprint out the error message, like this. That way, if something goes wrong, there's an assert, or whatever assert message got triggered, comes out at the end of the program. Okay, cool. Now, I need to finish writing the assert a little bit, because I didn't fill this in. So when it hits that, it should say, okay, it has a safe assert, therefore I want to long jump to the safe assert buffer, or the safe assert jump. And before we do that, we should also really set the safe assert message equal to, and this is, hold on, alright, there we go. And this is a bit of a fun part. So if I do that, that'll turn the condition into the assert into a string. And then I want to combine that with this. So I put this literal string next to it, and that'll make a literal string that has a colon and a space and then that. And then what I want is, let me see a compilation error. Yeah, so I want the name of the file. And I want the line string. Do I have, first of all, you gotta put spaces on all of these so that it doesn't accidentally interpret one of those as like a raw string or something. Do I have a string? Yeah, there it is. Let's pull that up here above the assert stuff. And so with that, I will add line string, which is just basically where you stringize the line macro. So what'll happen here is it will put in the name of the file, and then a colon, and then the line number, and then a colon and a space, and the error message. And so now I first have to long jump. I also have to pass to long jump that I want it to cause the original set jump to return 1 this time. So when that gets called, it passes execution back to the return of this function, but this time it returns 1. It goes to L, which is right here, and that will set the error variable that was passed into this macro. Okay, 4611 and 4805. Okay, now I'm going to have it just assert, or let's do a invalid code path, for instance. So now the first error in my message buffer here, it comes from that assert. And you can see what I did there was I basically said this format here is one of the formats for code recognizes for line jump, or like jump position. So it's got a file name, a colon, a line number, and a colon, and then the error message. And so I can, like, you know, be like this, and then go boop, and it jumps me to where the assert occurred inside the preprocessor when it ran the preprocessor. Okay, so there we go. We are all set to begin actually writing the GPU preprocessor now. Okay. So what this needs to do is it needs to load up this file called yeah, I've changed my mind on something. I was thinking about this earlier and thought I needed user32lib, but I'm taking that out. Okay. So the preprocessor is going to open up the file that's passed to it, and that GPU programs.txt is going to guide it on how to build the GPU programs for the main program. So what we want to do here is before we enter into that, what we'll do is we'll say if argc, I really don't like doing that. Okay, if argc does not equal 2, okay, perfect. So next, what it'll do is we'll go ahead and get that file. So that's going to look like this. We want, let me get all of my arena stuff real quick. So let me go to this, and let's see, I want memblock and arena in this code. And then what'll happen is we're going to initialize an arena. So take me to the arena code. arena calls it scratch. Make arena malloc mem size. I'll call that scratch mem size. And scratch mem size is going to be like 32 megabytes. Right, we're just going to grab a bunch of memory, use it, and then throw it away. And all my arena functions take arena pointers, so I'm just going to take a pointer to that. Okay. Now, I can do something like umemlen equals 0. How do I want to do this? What I should probably do is something like data, main data maybe, or file source, not sure. Programs. Load file. Scratch, and the file name will be argv1. And what we'll do is we'll say if programs.data equals 0, fprintf standard out could not load file boop boop exit 1. Okay, now write that up real quick. The load file function, well, first of all, a data will just be a U8 pointer and a size pointer, or and a size variable, right? A umem size, and then load file will look like this. It takes an arena, and it takes a file name. It's going to use the standard C fopen, read in binary. If we get a file, we'll do stuff. Now we want the result right here will initially be set to 0. So if we don't get a file at all, that comes out as 0. If we do get a file, then we'll want to remember to close it. But before we close it, we want to be able to do an fread on reading into the result.data with size of size from the file. In order to get that, we're going to want to do result.data equals push array onto the scratch U8 result.size plus 1, and then I'm going to want to push an align on there as well, and I'm going to want to I'm really going to want to push array fast, push that alignment, and set result data result size to 0. So what the push array fast does is it doesn't clear to 0 the block that I get. Now I need to get the result.size somehow. So I can get that if I ask it to just tell me where it is in the file stream, and then seek back to the beginning. And this will be seek end, and that'll put the file at the very end, and then I can get the size, put it back in the beginning, I allocate the space, I read from the file, and then there we go. And then what I want to do is fprintf file length u should be what you get when you take data.size. Now, first thing that should happen is I should get some compilation errors. Spell load wrong right here. Programs. think I did that wrong. Okay, let me go to my defines file. So it's worried because the goto label is still inside the same scope. What happens if I put all of that outside of that scope? Okay, now it's not so concerned. Okay, there we go. Now its main concern is that it can't load that file, which is the right thing for it to be concerned about at this stage, because I haven't written that file yet, and so that means everything is working, and I need to write the file. So GPU programs.txt. GPU programs. I should call it jam2 GPU programs.txt, right? Now here's a question. Should that be under game? Because that feels like the kind of thing that belongs under game. Well, we'll find out later. Yeah, here's an idea. I'm going to go ahead and say that we're going to put a name here as well. Generated jam2 GPU programs. Okay. And then the GPU preproc actually expects header name. There we go. That'll be better later, because I might want to have a situation where this is got, like, there are versions from the game code too, but now I can do it this way. Okay. jam2 GPU programs.txt. Alright, so what this file is it's going to be a made-up format that basically declares to the preprocessor what things I care about. So, for instance, I think what I want to do, this is a little bit experimental. I haven't done something like this before, or not something exactly like this. I've done a preprocessor for the GPU, but I want to do something a little better than my preprocessors have done before. So let's see. Yeah, so basically these are the two I care about, frag and vert, right? And what I want to be able to do is go file basic vert, and then I'm going to give the full name of that, like the full path to that file. So jam2 vert basic.glsl file basic frag jam2 frag basic glsl. Right, so that's just me saying the first thing in the line says capital FILE, means we're defining a file. I give the file a shorthand name for this script thing, and I give the path to that file. And by path I mean the name from the base of the code. Now that does raise the question, from where do I run this thing? And I'm actually running it from the build directory, but I'm going to change that. So this is going to run in build dot, or in slash build, and these will both run in slash build. And this will run in slash code, so that I don't have to do things like that and that, but I do have to do that. So I'm running GPU preproc in the code directory, and that way these things are all like one in the correct path, right? Okay, so that defines the files. Now what I want to be able to do is define the programs that I want generated from those. So what I could do is like shade, or I'm going to do vert. Vert will mean that I'm defining a vertex shader, and the vertex shader will include basic vert, what will the name of this be? Yeah, so it'll be something, I want to do something like I put in a name, and then I put in files, and then I put in, okay, so our syntax is going to go like this. File name, some kind of separation thing, a colon, bar. What do I feel like makes the most sense? A dash. I want something that, okay, a semicolon. What about that? So then this would be, hey there, Captain Craft. How's it going? So then vert would go like this. You put in the name of the vertex shader, which will be basic vert again, I guess. Then you put in the file that it's based on, which is also basic vert. Now I don't know if I like allowing that to have the name conflict there. So how's it going, Captain Craft? Anything cool? Anything cool going on? Let's see. There we go. And then I can do program is basically just the list of the shaders that go into it. So yeah, that's still sounds like you're still settling in. Makes sense. I'm anticipating moving sometime in 2018 at this point, I think, and I'm like easing into it really slowly because I can imagine that I'm not the kind of person who can handle moving very well. It's going to take me a long time to like fully get it done. Have I missed anything important? So one of the other things I want to be able to do is add defines here. So I'm going to just, for funsies, put a define in right here. And that'll look like width height box maybe. I don't know. So this could be like it's got no defines, and width height, basic vert, radius center, RC box. Okay. So there we go. That should allow me to test all the features that I want to have in this thing. So the parsing rule is like this. Each line is line delimited, so we read it one line at a time. On each line, we find one of these words, and that begins the declaration of a thing. Okay, now that I think about it, I don't actually need to do this by line. I could do it by token if I wanted. And my tokens would basically be white space delimited and semicolons, right? Anything that's delimited by a white space or semicolons is a in each semicolon is a separate token as well, right? And then the only problem is you process things in kind of okay, the advantage to that is that I could, if I have really long lines, put things on the next line. And let's see, what does the parsing look like? If it's by line, you first splice everything up into lines and you just process one line at a time. If it is by tokens, first you tokenize the whole thing, and then you do another pass that reads for each token. Okay, and when you're going by a line, you kind of tokenize the line once you get it anyways. Whereas if you tokenize first, your disadvantage is that you don't know how many like lines of actually useful information you have, but your advantage, besides the syntactic advantage for the actual script file, is you get to do all those tokens in one pass, and that could be useful too. You'd grab one token, be like, alright, which of these is that? You'd grab the next token, expecting an identifier to do... Yeah, okay, I'm going to do this by tokens. Just because the other one I did was by lines, and the fact that my lines couldn't wrap eventually became a pain in the butt. So I think that the extra work that in my head is involved in doing it by tokens isn't so much that it's not worth it. I think it is worth it. Okay, so that's basically my list. What is that called? txt. I'm going to pull the preprocessor up over here, and what we're going to do is, well, first let me make sure that I'm getting the correct file length. I'm not. So this is a little pro tip. Whenever I'm using the fseek, get the full size of the file and read it all into data method, I always, when I'm testing, the first thing I do is I print the length of the file after I've loaded it. Because if you get a length of 2, then you know you screwed something up. And the thing you screwed up is that you put these in the wrong order. And there's no way to remember that, so I've given up trying to remember it, and instead I just put the printf there and see what happens. Now what we can do is I want to turn data into tokens. So this is going to look like this. Token array programs tokens equals tokenize program scratch programs source. Okay. So here we're going to have a token. Our token types are going to look like this. Token type. Our token types are token. So these are basically like keywords. Keyword, token, identifier, and token semicolon. Those are the only keywords we care about. And then each token will have a type. In addition to a type, each token will have a start and a size. And that's about it. Okay. Now a token array will just be something like that. Maybe with that involved, but not right now. Tokenize. That takes in an arena for scratch memory and data source, right? And the idea is to come out the other end with a series of tokens that is basically like file, basic vert source, semicolon, jam2 vert basic.glsl, semicolon, file, basic frag source, semicolon, etc. And that is what we're going to do now. Okay, so the first thing I want is the result array. And the result.tokens will equal, and this is one of my favorite tricks with a memory arena, is I'm pushing an array of tokens of size 0. That basically says, give me the current pointer, give me the pointer of this memory arena at its current position, and then we can do a loop that basically is going to go over all of the source data and push one token at a time. As long as I don't push anything but tokens on, then I'm building an array legitimately, right, into the memory. Okay, so how does that look? Okay, so what I'm going to do is I'm going to go I equals 0, I is less than source dot size plus plus I, and then we're going to get 1 byte, which comes from the source data I, and I'm going to take a look at if that byte is equal to a semicolon, that means one particular thing. If that is white space, if that byte is white space, we'll do something, and otherwise we'll do this thing. Okay. So if the byte is white space, then do while is white space b. Plus plus I b equals source dot data I. So that'll just keep zooming ahead until we find something that isn't white space, at which point it will back up 1 so that the next time through the loop can read that. B equals that, or 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 B equals that. There we go. So if we see any of those things treated as white space, and let's see. And skip ahead, yeah. And then when we find something that's not white space, go back 1. Now it could be possible that we have like an array of 200 bytes, right? And the 200th, and the 201st byte is a null terminator because I null terminated my file, right? It's right there. So since it's null terminated, it could go to 201, read a 0, see that that's not white space, back up 1, now it's at 200, and no, here's it gets to 200, reads it, backs up to 199, comes up here, adds 1, and now it's at 200, and then it breaks. So that would be perfect, right? That'll end gracefully out of white space. Now, what about the semicolon? Well, with the semicolon, all I'm going to do is immediately push a token. So that'll look like this. New token equals push array scratch token 1. The new token type equals token semicolon. The new token start, that was weird, equals I, and the new token size equals 1. And that's all there is to the semicolon. And I also want to increment the results dot count. Okay, Now, if I see anything else, I'm going to treat all other characters as identifiers. So semicolons and white space are not identifiers. All other things will be identifiers. Now, if I want to have a file name with white space or semicolons in it, there's a couple of things going on there. First of all, I have a rule that I never put white space in any of my files, so I don't care. Semicolons aren't allowed in Windows, so I won't have that either. But what I could imagine doing is saying something like, look, if you wanted to have like weird white space in all of your files because you like, I don't know, like having to put quotes and everything, I could add another rule which is like an identifier could also be enclosed in quotes, and then even if it has white space and semicolons in it, that's considered an identifier for this language. But I'm going to put that on hold for now. Let's say like quote surrounded identifiers. If I you know, just want to have something fun to do, a little string parsing thing someday, I might do that. But for now, I'm ignoring that possibility and moving ahead. And let's see. Okay, so now what we're going to do is we're going to say what we have here is a byte. It's neither white space nor semicolon. Then I want to do a loop kind of like the one above that goes like this. Get the next byte while what we have is not white space, and while what we have is not a semicolon, and while what we have is not a null terminator. Right? If I hit the null terminator, then I will go ahead and stop there for that reason as well. Then when I get done, what we'll do is say, okay, no matter what I hit, I'm going to want to see that thing again, right? Because if it's a 0, then like above, I will just minus on the I, and then it'll plus and be too large and stop. If it's a semicolon, I want to see that and emit a token for it, and if it's white space, I want to skip ahead. So I'm going to do a minus I, but first I want to get the correct size for this thing. So the size is going to be, you know, I said I was doing umem on this, but I think it's U32. Okay. The size is going to be I minus start I. Start I will be a thing that I do right here. Okay. So that gives me the size of this thing. And then I can do minus on the I. And now I have the correct starting position. I have I in the right spot, and I have the size, so I can forget about the I iterator and just use start I and size to make my new token. Now, the only other question mark is this token an identifier or a keyword? So I'll have to get that figured out. Leave that unanswered for now. But start equals start I, and size equals size, and result dot count. Now, how am I going to figure out the token type? So we're going to say that it's an identifier to begin with, by assumption, and then we're just going to have a list of keywords, and if our string matches any of those, we will switch it to a keyword, right? So basically, if string match array, and string is going to be source.data plus start I with a size, and then we're going to have the keyword array. And if that, then type equals token keyword. There we go. Now I just need to implement this guy right here. So this takes in a string and a size, and then a string array. And that will have to do something like for u32i or j equals 0, string array j does not equal 0 plus plus j. U32 len equals string len of string array j. If len equals size, then if string in compare string and I compare that to, I want array string, with len being the string in comp length specifier. If those are equal to each other, then result equals true and break. Result equals false, return result. Okay, and then let me just specify keywords array. And my keywords right now are file, vert, frag, prog. Right? How's that look? Oh, you need a null terminator there. Good call. Okay, you're going to be pissy about that, so what we're going to do is we're just going to buckle and let you have what you want in this case. You want me to include string. That is cool. I can do that. Semicolon there. Keywords array. That's what I ended up calling it. Okay. Okay, and then what I will do, just to test that we're getting good results, is for each of the tokens in the array, we're going to get that token out. Programs tokens dot tokens I. Take the address of that. Switch on the type and f case token keyword. Type name equals keyword. Define case n. Case token glued to n, type name equals stringify n, break, undef case, case keyword, semicolon, case, semicolon, semicolon, case identifier, And was that all of those? Keyword, identifier, semicolon, yep. There we go. You can go away now. Default type name equals unknown or error. Type name equals 0. There we go. So that'll give us a type name. And then we're going to printf the token's type name, and then the token's text, and then a new line. And the way we'll do that is type name there, t size, and then programs source data plus t start. Programs tokens. Cannot convert argument 1 from const char 11 to file pointer. Ah. Sorry about that. Alright, so this says keyword, file, identifier, basic vert source, semicolon, identifier, that file name there, semicolon, file, basic frag source, semicolon, frag basic .glsl, semicolon, vert, semicolon, vert, semicolon, that looks good, frag, semicolon, program, basic vert, semicolon, basic frag, semicolon. Alright, so that demonstrates to me that the data for transformation into a tokens array has worked. Now, what I want to do is I want to process those tokens into basically, what should I call them? Sort of, like some kind of, I guess, objects, right? Each of these is a different object that I am going to basically pull out the definition of each object and make an array of objects. And I'll know, like, how many file objects do I have, give me all my file objects, how many verts do I have, give me all my verts, give me the file with this name, give me the vert with that name, give me the frag with this name, and so on. And then finally, all I have to do is take all of the programs, and for each program you get its vert and frag. And I guess what I should do is I should do this, actually. This needs a name, so this will be basic with height will be the name of that program. Basic RC will be the name of this program. And so that'll produce two programs with these two names, and that tells it, like, alright, pull that in, pull that in, pull that in, pull that in. When it pulls these in, it sees, okay, you gotta pull in this source and this source and this source, and that's okay, pull in this file and pull in this file, and so on. So it's a little bit of multiple steps of, like, iterating through this graph to find everything that everyone depends on, but it's a kind of a fixed depth, because programs depend on shaders, depend on files, which depend on the actual source text. So there's, like, at most 4 pulls on this thing until you get all the stuff you need, and that doesn't seem too bad to me. And I think that that will make it pretty easy to sort of expressively build up a list of your like GPU objects that you care about and manipulate them and whatnot. Okay, so I want to introduce real quick one of these guys. Is that the one I want? Take me back to search. Do you have any longer ones? Looks like they're all the same size. That's fine. Give me one of these. Alright, so data, load file, tokenizing. Okay, and then what we're going to have is the next layer down, we'll have a GPU object. And a GPU object is the general thing that is described by one of these. So it can have a you know what, now that I think about it, I think I've got something called a GPU object already. GPU program, GPU static object. Alright, and that is basically GPU static file, GPU static vert frag, GPU static program. Right? Okay, and so that will go right here. And then each of these has a name. So I think if that's something I want is, should I introduce a string struct into this scenario? I feel like at some point I'm going to end up buckling and just pulling in the four-coder string library, so I'm going to actually just do that now instead of waiting. So string name, and then after that, it basically has a list of strings, right? So each of these has something like that's one, that has 1, 2, that has, well, that's not really, yeah, that's a non-list of, okay. So this is not variable length, but this and this are variable length, and these are not variable length. So it's possible to be variable length or to have one thing, and you have one or two of those. So it's something like I think it's just an array of, okay, an array of strings would allow me to do like 1, 1, but how would it let me do n, n? I would need an array of strings, and then each of those arrays of strings would have to have a length associated with it too. So string array. I could just do strings, pointer, pointer, which is an array of arrays, both of which are variable length. Depends how do I want to do that? I could delimit them with 0, or I could give them counts. I feel like the number of depend types that you have should be fixed for each type. So given the type, I can figure out exactly how many are in the first level array, and then how many are in the second level array is a question that I could answer with a null termination. I think that's what I'll do. Let me fill up my water real quick. Okay, now what'll happen is, you know what, that's not quite going to work for me. Because I do want to be able to resolve those later. So this is more like static depend string name, and then GPU static object pointer. And so this is actually a GPU static depend array. Yeah, I think that's good. Okay. And then the next thing we'll do is I want to build the thing that just emits all of these objects. So what I do expect though is these are going to be variable width, and I'm just going to want to link them together like this. Do I have like a DLL or linked lists? There we go. Yep, we're going to extend this to have a SLL push, which takes a first, a last, and a node, and then this uses the do while idiom, and if first equals 0, then else this. Okay. And I'm gonna kind of compress this actually to save space. Alright. So if f does equal 0, then f equals L equals N. Else L next equals N, L equals N. Alright, so that'll let me do an SLL push, SLL pop, first, last, node, first, last, goes like this. How do you do that? If f equals L, then f equals L equals 0. You have exhausted the queue. Otherwise, they do not equal each other. F equals F next. So that pops one off the list. Alright. Alright, so there we go. Now I can make a singly linked list of all my objects. And the next thing I probably want to do is I probably want to go struct GPU static object set, which is going to be separate lists. So this is like files, verts, frags, progs. Right, so I have a separate list for each of those major types. It says here on OBS I've dropped a few frames. I don't know if anyone's caught any of that or if it's mostly working for you. but I haven't stopped to look if there's been an issue for a little while, and it looks like there maybe was one at some point. But I don't know. You guys let me know if you have any issues. Okay, and now we can finally write some code that does some operations instead of constantly defining data formats, which is, you know, it's part of the whole process of programming. You got to define your data formats. GPU objects equals, I'm going to call this parse programs source programs tokens, and parse arena scratch data source token array tokens. So I have a question from Squads25. Why do you use linked lists? For this particular purpose, the reason I'm using linked lists is because these data objects here, I'm going to build them one at a time while I'm parsing the tokens, right? So I have the tokenization for this file, and basically each of these things here, one line there, as it's parsed, is going to be turned into one of these static objects. And the length of memory I'm going to push onto my arena is different for each object. Yes, this portion is the same, right? I'll push this portion on, and that's like 1 pointer, 2 pointers. This right here is worth 16 bytes. That's 4 bytes. That's 4 bytes. So it'll probably be like 8, 16, 32, 40, 48 bytes that gets pushed on for this, right, every time I push it. But this points to an array that is going to be built is right afterwards. So like I see file and I push one of those, and then I go, okay, I'm going to need an array of 2 pointers, 2 subarrays, and then those, you know, we get pushed on as well. And the amount that gets pushed on, you see, like this is 3 strings here, this is 2, this is 3, these are 2, right? It's variable. The number of strings that gets pushed onto the arena is different for each object, which means I can't just push a single flat array of objects, because in order to do that, basically all of the strings that I allocate would have to go somewhere else, and I just want to blow through a single arena of memory. So what I'm going to do is I'm going to push an object, and I'm going to push whatever strings it needs, and then I'm going to link it to the next object that I pushed that could be any distance away from it. Then later I'm going to serialize those back into a flat order, but on the first pass I'm going to let the memory be a little bit spread out just to make it easy to write the code, because speed is not at all a problem on parsing such a tiny bit of text. It's really just about how quickly can I get this thing to be working correctly. Okay, so what this is going to do is we get this set, I'm going to call that. At the end we're going to return the set, and the nice thing about this is since it's all a bunch of singly linked lists, I don't have to initialize the first and last pointers. Them being set to 0 is how they get initialized right away, so that clear to 0 there means that I've now initialized 4 empty lists. Okay, then what I'm going to do is start a loop through the tokens. So that gives me a token, and then I'm going to look for I'm going to look for if t type equals token keyword, then we're good. Else we're going to do error, I'm going to set t start as the position. Here's the source, and the error will say expected static object declaration keyword here. Okay. And then I'm going to let's see. If I see the keyword, I'm going to figure out which one I have. So, debating what thing to do in what order. Yeah, I need some kind of match. So this gives me a string match that does a string array. I want another one that does just basic string match with string size and b string, I guess. And that will basically be what happened right here. Right? But it won't be a break. Result equals false. Return result. And then if string match string size string size AS, then result equals, then result equals true break. Now let's just reduce that down a little tiny bit. We could go one step further, since we don't need to use that twice now. And this is actually B string. Okay, there we go. Now, if string match, and that's going to say S equals, or actually it's U8, S equals source data plus T start, S T size file, and then I'm going to just build out a couple more of these. 1, 2, 3, 4. Whoops. Unrecognized keyword lexeme, right? So file vert frag or prog, right? And then these will go something like this. Squads25 asks, is this Vim? No, this is an editor called ForCoder. You can find some information on the stuff below, and I'll see if Insobot is with us. Yeah, Insobot is with us, and he just posted some information. ForCoder is an editor that I started a couple years back, just to make an editor that hits right the exact sweet spot that I like to program at, and you know, a few other people. It's got a little small called following now. But it's basically in Emacs without eLisp. Instead you customize it by just writing a C DLL or a C++ DLL or something like that. Okay, so now, what I'm going to do is each of these will begin by pushing on an object. Object equals push array scratch GPU static object 1. That gives me one static object, and then I'm going to have some helpers that'll basically be like, well, I guess one thing I should really have is like a reader. This is always helpful for me. And this has like a position and a token array, tokens, and so then you can go like reader equals make reader tokens, internal reader make reader token array tokens reader r dot tokens equals tokens return r. There we go. And instead of having this loop here, we'll just say for token t equals get token reader. I probably want to be able to do like this reader get token reader push, I'll call it. It gives me one token. And then I can do like if t equals null, then we break. Otherwise I look at the type, and if it's not a keyword, I throw an error like message to the user and I get out. Otherwise I look at the name of the keyword and I do one of these. If it's not recognized, I have an internal assert and I get out. And then for each of these I'm going to push the object and then basically do parse single. Here's the reader, here's the object. You're going to want the reader is also going to want, now that I think about it, the source. Alright, and then parse single reader object. Now, one question is, when I first initialize the object, it doesn't have one of these, and the depend count is 0. So I kind of want actually to rethink this. Maybe I can't do an array of depends here. Maybe I need a linked list of these as well. And so the way that would work is okay, yeah, I'm going to change this. So this is not right. You go away. We're going to switch this over to a struct GPU static depend, being something that can point to a next. It has a pointer to the result. Well, it's just going to have the name. We're going to have to deal with something different there, I think. I'm not sure. We'll see. But then I'm going to do depend list. And a depend list has a pointer to the next list, and it has a first and last in its singly linked list of depends. I'll put a count there. So now this list has a list of depends in it and a count, and it can go to the next list. And then this guy here can have a first and last list and a list count, right? Okay, so that's a bit different. But that will let me do this in any order I want at all, which will be even better. And then I can say parse a single, and that'll throw an error to the user if that's not a single. So I'll do like, if this is a failure, then CryZ92 says, why U32 for counts and indices? Isn't that slow? Why would that be slow? What would you recommend I do for counts and indices that would be faster? Alright, so if I can't parse a single, we're going to do an error. Yeah, I can't do it that way. Yeah, okay, no. Maybe at some point I'll have to think about how to do smarter error messages than that, but that's what we're going with for now, is this. So parse single from the reader, and then parse another single from the reader on that object. And then CryZ92 explains why U32 would be slow, because the compiler has to emit an extra instruction to follow the wrapping rules for an unsigned 32-bit counter when you add one, or when you add anything really. So basically, in other words, it has to enforce the wrapping rule, which is not the case for i32. I, for one, don't like the fact that that's not the case for i32. I don't use U32 just because i32 doesn't enforce that. But maybe I should switch to U64. That's not a bad thought. I don't know. I don't particularly care about that, especially in a case like this. If it was killing me and I looked into it, and that was the only thing I could possibly do to afford to switch. That's the only switch I could make that I could possibly do to afford a certain operation. I would make the change, but I like using U32 because it is like basically, as much as I can use U32, it prevents me from getting into places where I have to convert back and forth, which just always annoys me. So once in a while I have to handle an actually signed thing, but in those cases I think explicitly about okay, the signed thing is going to work this way, and I can plan it out. And if I'm not planning stuff out, I just go unsigned because it behaves correctly under all circumstances. And then when I need speed, I'll think about, okay, should I do something more clever here to not pay the penalty of the thing that always behaves predictably for me. I don't know. At some point I just decided to just always take the path of least resistance towards correctness and then do speed when speed matters. Like as a second concern after the thing is correct. So I don't like write code intentionally piggy, like this will never be optimizable, but more like here's the thing that makes it easy to get it right, and then do speed as a second pass if the thing that you did right was not dialed in as much as it needs to be, I guess is the way to do it. And by right I mean like not as in like the code is correct for the problem in some abstract sense, but it actually just solves the problem without bugs in as many cases as you can make it do, I guess, is what I'm trying to say. Alright, so the second one here is the vert, and the way the vert works is it has a single name right here, and then it has any number, or this is actually like a situation where it's one or more, and then any number, and then it's finished. The this guy's the same, and oh, the other thing I have to do is SLL push the set dot files first, set files last of the object. This one here is not files, it's verts, and this one is frags. And okay, now one more. Push in an object. It, like all the other ones, parses a single out first because it's got a name. It parses out two more singles for the vertex and fragment shader, and then we finish it and we push it onto the progs list. Okay. So there we go. That's basically the way the parser is going to look, and now I just have to implement all these functions that I imagined that aren't actually there. So let's get into it. What have you got for me? Alright, first things first, let me do a little bit of work here. I'm going to pull up the 4-coder string library because I don't feel like writing a new one. I don't see any reason why I would want to do that. I like the 4-coder one, so I'm going to just pop it in here with everybody else. There we go. And then up here, I imagine I'll end up using it in the actual game code too, so it's just better this way. Okay. Make reader. Oh, it doesn't know about the fact that it also takes a source. Reader push. Okay. So reader push is going to return a token pointer, and it's going to look like this. Pass in a reader. Token result equals 0, return result, and then if reader position plus 1 is less than wait, no, if reader we gotta plus the size, yeah, plus 1 is less than or equal to reader tokens count, then what we'll do is the result equals the reader tokens plus the reader position, and the reader position plus equals 1. Or, I guess to put it another way, plus the reader position. And that returns the result. And that's good. Parse single. Okay. So now these parse functions, you have to write those real quick. They're going to work like this. Now that I think about it, they all need to take the scratch wheel while they're doing their work. Single, one or more, any number. Single, single, single. There we go. Alright, so this one takes an arena. It takes a reader, and it takes a GPU static object. Okay, and what this one wants to do is it wants to see an identifier, and then it wants to see a semicolon. And so the way it does that is token T1 equals reader push reader. If T1 equals 0, error let's see, how did my error function look? Yeah, the position. Okay, so the error is at reader source dot size -1. I believe I pass in the source with that. Yep, and expected to find a single expected to find an identifier. When file ended, but file ended. Okay. If T1 dot type does not equal token identifier, error on this, in this case, the T1 start position, expected to find an identifier. All right. And then token T2, reader push one other token. If T2 equals 0, again, what I should have is like a error position EOF constant that deduces this from source, so it'd be better. Error position EOF. That'll work. Okay. Expected to find an identifier. Expected to find a semicolon, but the file ended. Alright, if T2 type does not equal token semicolon, then we have an error that looks like this. To find a semicolon. Okay. And now, if we get to the end of that and we haven't hit any of those errors, then we have a success, right? So now what we want to do is find the information and put it into this object. So the way we do that is first we need to push a depend list on here, and I have to do one thing different. Yeah. Is name. Yeah. So if this is a name, otherwise we'll do something different. Alright. So I got to fill these out. Parse single. The first one is always the name. The others are not. Parse single. Just give me a list of all the places where I wrote that. True. 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 False. Okay, perfect. Alright, I'm going to resume in like 5 minutes, possibly 3. I just need a quick break. Fill up my water and stuff. So I'll be right back. And I'm back. Hey there, Rupin3. Yeah, I enjoy whiteboards. I think I like chalkboards better for a lot of purposes, but uh, the maintenance on a whiteboard is better. And the only issue is I stopped using that whiteboard for like a year, and it's just been hanging there, and now it's really hard to erase the stuff that's on it. So I've erased a few of the to-do items that are on there. There's like, some of the items on there are like four-coder to-do items. And I've like gone in and erased a few of them, and it's slow going, it's tough. Okay, So this thing here is concerned that it doesn't know what my error function does. So I'm going to go implement that real quick first. Then I'll get back to everything in that parse stuff. Internal void error takes a position, a source, and a message. And I'm just going to do the slowest possible thing, because the good news is I'm only going to handle one error at a time. It's not like I'm going to emit 10 errors and then keep trying to parse or something like that. I'm not going that far into this. So I can just get away with doing line number equals 1. For u32 I equals 0, I is less than position plus plus I. Plus the line number. Alright, so for each new line character we find, increase the line number by 1. Then, f printf standard out so that'll be source dot file name line number, that should be a U, and message. Alright, and then I'm going to do something up here. This is not right. This is like file. And I'm going to include file name in there, and result.file name will just equal push array fast scratch char file name len plus 1 len equals strlen file name push align scratch 8, and then block move into the result.file name, the file name, and file name len plus 1. Okay, so that will set the file name on our file in a scratch allocated string so that we can do any general string pass in there that we want, and it should be fine. Now, error. Yes, so source name, yeah, okay. And then new line, okay. And then what I want is like assert silently, right? Or like, yeah. Like basically a fail kind of thing. I'm going to do assert silently. The way that's going to work is that in the defines, if you don't have safe assert on, assert silently will just be assert. But if you do have it on, assert silently will be, alright, do we have a safe assert? Yes. We don't set any message. There's no assert silently is like there. There is none of that, and there is no this. And yeah, so there it'll just fail no matter what. Here it will fail without sending a message. CryZ92 isn't what undefined behavior. To write to 0? Yeah, it is. On my computer, it operates as my assert. When I just want a quick, cheap assert that is easy to write and causes a crash. Although it could easily cause, you know, non-crashes or actually write to real memory on embedded systems. That's never going to be where this code runs, so I don't care. It's never supposed to trigger in a working program anyway, so I'm okay with that being undefined behavior. Alright. No, I'm not, because it doesn't. Like, I mean, it could in another case, but I'm using it for my debugging purposes, and in my case it does not. It does hit those zeros all the time. So I get the crash that I expect, and that's why I use it. If my compiler wasn't working, then I would stop using it. But for my particular compiler, it does what I want it to do, so it works. And hey, worst case scenario, if the assert was like superfluous and it does get optimized out by someone else's compiler, then hey, that's a win, you know? I don't expect that would happen. I mean, I know that on this and on my Linux laptop, the compiler, that assert works there too, for causing a seg fault that I can stack trace. Yeah, it serves its purpose. Anyway, so this is basically a way to assert without putting out an error that jumps me here, because my assert in my safe assert zone would normally output an error to the command line output, but I actually want to see this is the error, not this in this case, right? So what do you got for me? Right. You don't like that. Let's call you a umem. Okay, now what I need is error position EOF. That's lame. Alright, error position EOF. I'm gonna go ahead and say that's super lame of you to be signed, and let's just do something different with you instead. Alright, cool. So parse single is up and running, except I haven't implemented the isName part. So if this is name, then what that is used for is to set the object's name field, which each object has one, right? Yeah. So the way that'll work is we just call make string cap. I have to open up the string file to get the autocompletes, right? There we go. Okay. So make string cap will work by going, give me the reader source data plus the T1 start. Let's see. Size, mem size. So the size will be the T1 size, and I'll give it a no mem size to indicate that it's not memory that it actually owns. Okay. Now, if this is not a name, then we're going to create a new depend list and push it onto the object's list of depend lists, and then push a static depend onto that. Right. So we need basically these two guys to help guide me. Alright, so I'm going to take one of these called the depend, and I'm going to take one of these called the list, and yeah, those both get it to 0, and then I'm going to do SLL push list first, list last, depend plus the list count. So that takes care of that. The list itself needs to be pushed onto the objects first, object last, list. And does the object have a count? Yeah, so plus the object's list count. So there we go. We've pushed the list onto the objects list, and we've pushed the depend onto the list. And then finally, we just have to set, let's see, let's do that one first, set that, and then finally the depend name equals, and it's this up here. So what I'm going to do is say string equals this, and that string either goes there or there. Perfect. Okay. SLL push. You're not familiar with SLL push. Oh, I need to actually include my linked list header. To linked lists. Alright, now let's write finish object. How does that work? Well, the idea of finish object is just to emit an error if there's actually more information than there's supposed to be. So there's not actually any changes that need to be made to the object, which raises the question, why did I pass it in? It's a little bit silly. Reader object. We're going to replace that with just object reader. Yes, 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 yes. Okay. And then I just want to go token tn equals reader push on the reader. I'm going to say temp read temp equals begin temp on the reader, end temp on the temp. If tn equals 0, then we're good. Right, if tn does not equal 0, then if tn type does not equal token keyword, then we're getting something, either it's an identifier or a semicolon, so this isn't actually properly ended. It's doing more than it should be doing, and therefore we're going to emit an error at tn, reader source, expected the more information provided for object than expected. Okay, there we go. And now I need to go implement these things. Boom, 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 boom. Internal, do, 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 do. Okay. Okay, so that is just there to let me sort of do temporary reads that then roll back to the position where the temp started. To basically let me peek at an arbitrary number of tokens and then roll it all back. So something like this. And that's, alright, that's good for finish. What else have you got? Ooh, you don't like, oh, you want me to put a start there. One or more. Alright, so the way this one wants to work is we know we're going to, this isn't like the name one where it's possible that we're not creating a new depend list. So we're going to start by creating our depend list actually. And then what we're going to do is say, let's basically just do any number internal U32 ident count. The idea here is I'm going to do one thing that can do both the one or more and the any number. And the way it'll work is it'll just do the whole thing and return an identifier count. And if it's a number that's illegitimate for the call, then it will just say error from there, right? But this can implement basically the primary logic for both of those. And that's going to look like this. For loop forever get a T1 or just get a T reader push onto the reader. Now if T equals 0, then error position EOF reader source expected to find semicolon at end of list, but the file ended. Okay? Alright, so if it's not equal to 0, then we're either going to see an identifier or a semicolon. If we see a keyword, then that's another error. Expected identifier list found a keyword. Okay, so if it's neither of those situations, then it's one of the two good ones. So if the type is semicolon, then what we'll do is we will break. That's it, we're done. We've read the whole thing. Else, It's do, 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 do. It is something we want. In particular, it's an identifier, and we're going to put that identifier in a depend and put that onto the list. So it goes like this: plus plus the ident count. Oh, we don't need that. Okay. So this is just going to return the list count. That's better. And so this just pushes a new thing there. The depend name is the string you get when you take the reader source data plus the t start and the t size with no memory for the string to expand or shrink. And then you push that onto the list. And then when all of that is done, we can push onto the object. Hold on, I'm just thinking. Yeah, okay, I'm going to do it this way. Alright, then you push that list onto the object there, and increment list count. Okay. And now, the thing I actually wanted to implement, which was parse one or more, which takes the same, has the same signature as that, calls ident count equals parse any number internal scratch reader object if ident count does not equal or equals 0, then error at how do I want to get the correct error position? Something like t equals reader current reader t start reader source expected identifier list with at least one member. Okay, and otherwise that is it. And then I can do any number like so, and it just doesn't do that. It just calls that without without caring. Okay, now I need to implement this part. Push. Alright, now we're getting somewhere. Now, I have a set of GPU objects, and I want to loop over each of those sets and look at all the objects I have. So, let me pull up my preprocessor on the other side here, and look at the sets of objects. And I'm just going to make a print object list thing that lets me pass in a GPU objects, files, verts, frags, and progs. Now what each of those will do is just to just to verify that the data has been transformed in the way that I think it has. It's going to go over each of those like this. So the list has a bunch of objects in it. List first, object does not equal 0, object equals object next. I'm going to do fprintf files, verts, frags, and progs. Okay? And then for each of those, I look at an object, and for that object I go, okay, fprintf out, the name of that object, colon, space, and then other stuff, and that name I get printed by going like so. And then I'm going to take that object, and I'm going to go, alright, I'm going to go over all of your lists. So here we go. For GPU static depend list equals object first, list does not equal 0, list equals list next. At the end of each of those lists, I will print out a single semicolon and a space. And then through that list, what I will do is I will take, and after that, by the way, I'm going to print out a new line character. And then, inside that list, what does it have? It has some depends in it. So I'm going to do a GPU static depend equals list first. Depend does not equal 0. Depend equals depend next. Printf to the standard out the name of that and a space, or how do I want to do that? Yeah, I'll do a name of that and a space. Alright, and depend name size, depend name string. Alright, so what results did I just get there? I'm going to pull compilation up here. I've got files, two of them. One of them is called basic vert source, and this is its, data, and frag source is here, and then there's its data. That's good. Under verts, I have two. There's the name, there's the source file, and the macro switches. Frags, again, source file, macro switches, and programs. Yeah. So it looks like all that data came through the way I would expect. Which is good news. So next, right now the data is all laid out in these long, flowing, singly linked lists all over the place. I want to get it tighter now. So the tighter version would look like is instead of having a list of names where each object has a list of names and those names refer to the other objects, I want to now start I want to do a pass that resolves all of those names. So basically, each object has a pointer to the object that it literally connects to, right? So the list of depends would no longer be a linked list, but an array of pointers, and those pointers point directly to other objects. So the way I'm going to do that is these are all going to get renamed to include some kind of oh, excuse me one second. Okay. Okay, so these are, I want to name these in some way that indicates that they're part of the first pass or the pre-resolution or something like that. I'm going to do unres. GPU static depend. Ooh, that's not right. GPU static depend unres list with list unres. Okay. Oops. GPU static object unres. Unres list. I'm going to rename that to unres list into list unres, and then unres set into set unres. There we go. Type unres. Now those will just remain as they are, unchanged, because those are the same. Okay, so those are the unresolved versions. Yep. And now I'm going to make the GPU static object set GPU objects equals resolve objects scratch GPU objects unresolved. Alright, now this is going to be the way I want the objects to actually be laid out in memory. So object unres. So the way he looks now is not the way I want the final one. Static object is going to look like this. He's going to have a type. He's going to have a name. That stays the same. But he's not going to have any of this. What he's going to have is a list count and technically if I put that there that might be better, but no. List count and an array static object, so an array of pointers, an array of arrays of pointers. That's a triple star right there. I might introduce a type def for that, like GPU static object link, for instance, star star lists, or actually what I should do is static object list, and just call that lists, because what I actually want to do, static object list, is I do want to have an array of lists, because each list needs to store static object links or objects and count. Right, so now what I have is this is an array of pointers to objects, and the number of pointers we have. This is an array of those lists and the number of those that we have. Okay, that boils down really nicely. And object list unres. And then finally we want a set, resolved set of object lists like that. Cool. Okay. So what now happens is I write the thing that does that. It returns an object set. This is the thing that resolves objects. It resolves them from static object unres, unresolved, and an arena. Alright, and so here's the new set. And the first thing I want to do is for each of these, we're going to go set files count equals, ooh, these don't have a count. I'm going to have to go add that. So files.first plus plus set files count. File vert, file frag, file prog. Okay. Whoops, you keep that. Set files count, unres. So the unres list now has a count on it. So I go unresolved.files count and set.files.objects equals, and I push an array of GPU static object pointers, and I get this many of them. Alright, so there's files, verts, frags, and progs. There we go. Now, for that's 4 arrays of pointers. Now, I also want to actually have the objects. Now that raises a question. Why would I store those as arrays of pointers when I could just store them as arrays of objects? Up here I needed an array of pointers because they're pointing all in a graph to one another. But that right there seems wrong when I consider that this doesn't really want... Okay, so change these aren't object lists. These are going to be GPU static object files, followed by a file count. Vert count. Frag count. And prog count. I feel like I'm going to regret not having struct that. So GPU static object array. Count static object objects, and this becomes GPU static object array files. Okay, that's the way to do it. Ooh, can do this way. Files, count, objects, and then I just need to eliminate these. And there we go. Now we have allocated all the space for the static objects. Now, I want to visit all the static objects and resolve their set their names and types properly. So for that, I'm going to do like resolve object type and name, and what that's going to take is it's going to take one array and one list of unresolved, one array of resolved objects and one list of unresolved objects. So file, we do that for frag, we do it for vert, and we do it for prog. So that takes a static object array and a static object list on res. And then what we do, besides asserting that we just didn't screw anything up, is we go, look, I want to look at that unres list. I understand that it has an unres object. So we loop over that linked list of objects, and at the same time I'm going to keep an I right here. We increment that. At the end we'll assert that the I got all the way through, and then for each of these we just go, look, I want the array objects I dot type to equal, and I guess I should actually pass in the GPU static object type as well. They all get their type that way, and then they all get their, let me get this up here, so this hangs out right here. Actually, why don't I do dest object, assert that the dest object equals the array objects plus the array count. That's good. And that lets me do dest object type equals type, dest object name equals object name. Right? So now I'm setting type just by looping over them all, and I'm setting the name from each of the unresolved objects into the resolved object, since they both use the same name. And that should give me an array of objects that all have their names and types set up. Next, what I want to do is I want to have an additional array here that is called all. And the way that will be made is that all will just equal files, all dot objects will equal all of this stuff here, except we'll put a 0 there, so it just gets the pointer to the first one, whatever that may be. And after all of this, it gets a count, which is this plus this plus this plus this, where all the other thises are things like progs, frags, and verts. So there we go. That gives me an array of all of those. And now what I can do is say resolve dependencies, and then I pass it the files. I pass it the unresolved files again, because that has the dependency information, and I pass it the all, so that it can see all of the other things. And then again, I do that for vert, I do it for frag, and I do it for prog. Okay. That takes everything that this took, except for the type, and it takes an additional array called all. Okay. Now, something again will go like this, it'll look like that, and it will look like that. But what we do in here will be quite a bit different now, because now I have an array of all of the objects. And so what I'm going to do is for each of these unresolved objects, that unresolved object, although it isn't resolved, has all of the names that I need to make a resolved version. So the destination object first needs to set its list count, and it'll get that from this object here. And then we're going to need the arena in this one. Because here we're going to start pushing arrays in. So the dest object, the resolved object has depends. It should be saying depend count or something, right? So the depend list count will come from the list count of the object, and the depends of the object will come from the scratch memory as so. Static object list. Count. Okay, so that gives us a new array, and then we loop over right. So we want dest list to equal the first thing in this list here, and then we're going to do GPU, let's see, his unres list. We're going to loop over his unres list, so list equals object first, list does not equal 0, list equals list next, comma plus plus dest list. Now, given an unresolved list and a resolved list, how do we create the and it's base for a resolved list, how do we create the resolved list? Well, first the counts should be the same on the two. And then we're going to want to push an array again. So the destination list has this array called objs, which is a static object pointer array, and it has this many of those. And then we want to visit all of the static depend unreses. So this is a depend, which comes from the lists first. We don't want that to get to 0, and we want that to go to its next. We're also going to want a dest putter, I guess, dest object putter, which is going to be this guy, dest object putter. And the dest object putter needs to get assigned. Now, how do we assign it? And this is where we actually do a name resolution. So far I've just been looping over these sort of nested structures of allocate the list for each object, allocate the depend for each list, and now finally we're looping over each individual depend, and we're going to turn the name of each depend into a pointer and store it here. So this is going to be like GPU static object putter equals 0, and then we're going to write the putter right there, and we're going to have a thing that's like, if the putter is still 0 at the end, then that's an error, and we're not sure all of the information about this error yet, but it's something like question mark, wait a minute. This isn't quite right, because although this is kind of true, these names don't get resolved, that's true. There's also other strings. These strings remain strings, and these strings remain strings. They don't actually resolve to other things, which means I haven't done this correctly. Alright. Let me slow down for a moment here. Alright, I see what we have to change. So let me go back to the preprocessor. The basic problem here is, first I need a data structure option that determines whether the resolved version contains a pointer or a string, because it could be either one, right? So this isn't quite right at all. Alright, so there's two types of these. Static depend could either be an object or it could be a string. And so this guy here is going to have a static depend type and a count, and then he's either one of these or one of these. Okay. And then the resolve dependencies will say, look, given a particular object type, it's required that this is always the same. So what we can do is say, here is a list of static depend type, expected depend types, expected depend types, and depend type count. And what will happen is, right here, we're going to assert, or we're going to say, if the object, no, this is an assert worthy thing here. If the object list count does not equal the depend type count, then we have a problem. And then we can go depend index equals 0 plus plus depend index. And what this will do is, yes, we do all that the same. These object list things need to be depend list, by the way. But as it's going over the unresolved depend list, it says, alright, list, you have this count here, but before we allocate our objects pointer and do all this work, what we need to figure out is if that is the correct thing to do for you. The way we figure that out is we go to expected depend types, depend index, that gives us a type, and the count is the same either way, but we only do all of this if this turned out to be equal to this. Whoops. Otherwise, if it turned out to be equal to this, no, not count, string, we do something different. And if that didn't happen, then we have, we'll do an invalid code path. That shouldn't be possible. We could, of course, implement that as a switch, which I prefer to do. So, okay, to do. Now, where was I? I want to do this next. So, I push on the list, an array of object pointers. I'm going through each of these things, and I'm saying, hey, what's the dealio? And it's saying something back to me along the lines of, here's the depend you wanted. Alright, let's look up that pointer, maybe. And the way it wants to look up that pointer is, it has some string that it's going to test against other strings. Yeah, okay, so for u32j equals 0, j is less than all count plus plus j. We are now going over the all array, and we're saying, okay, GPU static object test object equals the all objects j address if there's a match between the test object name and the depend name, then putter equals test object and break. If we get out the other end and putter equals 0 still, then the error does in fact go through, and it's something like this. The string came from the depend name dot string source, and then this is identifier for GPU static or GPU object not recognized, And there we go. If that doesn't happen, we set that dist object putter, and then we go to the next step where we get a new depend and we do the next search we need to do. But if we're making a list of things that don't need to do that, then our behavior is quite different. We don't make an objects putter at all. We make a stirs pointer, which we create by making an array of strings, and then we make a string, a dest string thing like this by taking the first of that. We do a loop just like this one, except that we're iterating over dest strings instead of dest object pointers, and then all we have to do is set the dest string equal to the depend name. There we go. Alright, so there what I'm doing is I'm just getting the position of an error from a pointer instead of from a position, and then passing the task of actually doing the work off to the original error function. GPU static file prog frag vert. Alright, so this one I need, let's see, pull up my programs here. So this one has a depends array of the following. So this is a GPU depend GPU static depend type. This is the file dep type. Which contains a GPU static depend string, and then here I just pass, I'm going to call this just file dep, and the array count of the file dep, and that's going to be basically done on all of these, except instead of file it's prog, instead of file it's frag, and instead of file it's vert. And then we're going to want for these, for vert, frag, and prog. Now let's see, what else do these guys have? This one here has object are its types. Let's see, that one has this one here has object string are its types. Okay. You also want the source, right? Now I have a static version of that. Alright. I just want to make a couple quick changes. What happens if this is the size? What if this is this? Wait, what if this is the size? No? Okay. So that answers the question. What I have to do is I have to try something else, like this. Perfect. Alright. So for this one, I'm going to rename this to S. Perfect. Alright. And now, after it's done resolving, I'm going to say alright, so again, we're going to do a loop, but this time it's a I equals 0 loop across an array. And for each of those things, I'm going to take a static object. And then I'm going to print out that object's name as before. Now again, I'm doing this, but I'm not going over an unres list. I'm going over a array. And that array is right here, depend list count. So then I can get my GPU static depend list equals the object's depends j. And then one more time, I can do a loop over this, like so. And I can print out for each of those. But one thing I do need to do is I need to look at which kind am I dealing with, which kind of list. So list type. Case GPU static depend object looks like this. Static depend string looks like this. And the way those will go is, as I'm going, I get the GPU static object putter by going list objects k. And then I go putter name, putter string, whereas in this case I'm going along and I get the string putter by going list strings k, and then I can go like this. Alright? Okay. And then I can print those by going like this. GPU objects files fprintf standard out files. Alright, so let's see. File prog, file prog, file frag, file frag, file vert, file vert. Whoops, that should be a does equal. And there we go. So I'm still getting everything, and now it's coming through that sort of crunched down, compacted form, data format, so that I can just do loops over in-place memory arrays instead of linked lists. And so that I can link directly to a dependent object, or like an object dependency, rather than just having the name of the object dependency. which is actually the real reason to worth. It wouldn't be worth just flattening those arrays, except that I also had to resolve the object names anyway, so might as well. Okay, so now the next question is, can we generate the header that we need from that data structure? Because that was the data structure I imagined in my head at the beginning of this, and now that we have it, is that actually sufficient? I think it is. So the way that that would work is I would first, for each file, I would loop over the files and create a thing that puts that file into the header. And that's actually all we need to get this party started, because the rest of the code that I have in the main game doesn't need anyone else to tell it how to create the shader programs yet. But we're going to evolve it towards that probably in the next session. But if I can, at this time, I've got the data, like the parse done. I have the data I need. Then the question is, well, first of all, I'd like to do a little bit of experimenting. I'd like to see if I can get an error message that looks right. Oh, let me put that back in. That's weird. I should have liked to have gotten an error message there. What if I have this? Okay, so that does jump to that line, which is good. Expected to find a semicolon. Very good. Suppose I do this. Good. Now suppose I do this. You expected to find a semicolon. Yes, good. Alright, and a couple more things about this. Good. Alright. What if I did this? Cool. What if I did this? Cool. Alright, and then last thing, what if I give you a name you don't recognize? Okay, that you did correctly. That didn't bug you. That bugged you. Okay, cool. It looks like this actually does work. Good. Then let me go ahead and generate a file from GPU objects for now. So basically what I want to do is I'm going to open up the output file. argv2 write binary if out does not equal 0. Really, I could try to open this like right away, like at this point. F close out, else f printf could not open file blah for writing for output argv2. Okay. Alright, and now I want to generate inline source text. So the way that'll work is I'll pass the output. Handle. I pass scratch memory because that may probably come up, possibly. Yeah, definitely. And I pass the GPU objects dot GPU objects dot files. Alright, so that's going to look like this. Generate inline source text. Takes an out handle, arena, and what else did I pass to that? A GPU static object array. Files. Alright, now I can do a loop over the things in that array. Each of the things in that array has a name, so I'm going to print out the output file. Char global char star, and then a name. The name of the array, square brackets, equals, and then what'll come next is the actual text of the file. So to do that, what we have so far, I need the static object at that place, and the static object's name will go right here. Alright, so now this is what we generated. You can see it's not good code yet, but it's getting there. The other thing we have to do is, given one of these objects, we're going to say, first of all, things like the depend list count should equal 1. Bring back the preprocessor, please. Go to the object. So then give us the GPU static depend list. List is just the objects depends 0. That gives us the first list. Then we can assert that the lists count should equal 0, and that its type should equal GPU static depend string, and by 0 I of course mean 1. And then I can get the string called the file name, which goes like this. List string 0. Good. And then what I want to do is I want to get file called the text, which is going to be gotten by going load file. And I'm going to go up to load file and we're going to look at it, because it's not quite right, is it? No. It should have a length specifier coming in, file name length, so that this doesn't have to be done. Now this one just has to pass in the string length for argv1 by itself, but this one appreciates the fact that it doesn't rely on null termination, but we have a new problem. Since it's not a null terminated string anymore, I can't fopen with it. But what I can do is I can push this and I can say that we're going to have a temp memory here. Again, temp on the scratch. And if we fail to load the file, then we'll end that temp. So that's a restore point that we can restore to if we fail to load the file. And we will also set the file name to null in that case. And so then what we can do is we push on there, that, we do the block move this way, and we set the file name len to 0. Now we've null terminated the string, and we pass that in here so that it doesn't complain that there's no null termination, because there is null termination again. And if that fails to open, then we release the memory we used to store the file name by reverting back to that restore point and setting that to 0. Alright, there we go. So now we can load this file by going, here's my scratch, here's the file name .string, and here's the file name .size. Okay, now what we need to do is include that text all right here in this little spot. And the way we're going to do that is by fprinting out open quote r, let me see if I can remember how to do this, r open quote, we're going to do foobar parenthesis, then we're going to drop in the text, and then we're going to do foobar end quote semicolon new line, and then we can just do text dot data text dot size. It's going to complain that that's too big. Is it temp begin? Ah, I changed it. That's so bad. I'm not. No. I do not accept. Temp begin. Alright. Begin temp end temp. Begin temp end temp. Okay. So what's going on over here? Char star. Try that. Alright, so there we go. So now what's happening, as you can see, is that the text called basic vert source has been dropped right here by just loading it out from that file and wholesale dropping it into a header. And so now all of my GLSL files are separate files, and then the first thing that happens is I compile and run the GPU preprocessor, which drops that all into headers so that I don't have to load files in during runtime, right? So the runtime has the text built right in as if you didn't use a separate GLSL file that you load in, but the preprocessor, it does the loading in for you so that you can have the separate GLSL file. Now, this here, I can just change this to say basic vert source everywhere, and it will understand. And same thing with basic frag source. Oops. Basic frag source. Let's try that again. Basic frag source. Exited with code 1? What you exited with code 1 for? That can't be right. You did the whole, what? Ah, there's an extra popd hanging around. Hey. So there you go. That is the start of this. Now, that's about as much time as I have for today. So I'm going to let that sit for now. I will do a little bit more tomorrow. So basically, if you're interested in anticipating what's coming next, so far all I'm doing is very basic. This could have been done in a much simpler way, obviously. If you look at how complicated my text file is here, this program declaration script, all I really have used so far are these two lines. They take in a file and dump it out and give it a particular name, right? That's all I've done. But all this other data I've connected to it will allow me to do more stuff, basically, automatically. And so next time I'm going to automatically generate stuff from this stuff, these lines here, so that I don't have to manually write a bunch of things that are really kind of very tedious, boring shader management stuff. It all just gets figured out from here, and then I can just use GLSL files to write my shader code, and I use this program declaration list to instruct the instruct the automatic shader handler to put them together the way I want. And maybe if there's time tomorrow, I'll even make it do nice compiler messages, because I like to have nice shader compiler error messages. When I hit the compile button, I want to be able to jump to my GLSL file where the error happens, and that's possible. So I might mess with that next time as well, if I get to it, but that would be a little bit later on. It would be next weekend if I didn't get to it this weekend. But anyways, thank you so much, everybody, for coming to check this out. I don't know how much of the stream got lost on dropped frames. It looks like a lot of it did, which is unfortunate, but what can I do? That's as good as I was able to make it this time. I will see you guys around. Bye-bye.